Bienvenidos, Ushamdeed, and welcome Anne Arundel Community College learners from the CTS-131 Section 402 course for the spring 2021 semester. This is the Cisco Networking Academy Switching, Routing, and Wireless Essentials version 7 or SRWEv7 course curriculum. And in this packet tracer tutorial and activity, we're going to be taking a look at how to configure Etherchannel. And what I love about this activity is we get to configure Etherchannel in a number of distinct and different ways. So we're going to be configuring what they refer to up here, and you'll see it says configure basic switch settings. We're going to throw a host name on there. I'm going to do a few other things. We're going to configure Etherchannel with Cisco's proprietary PAgP, and I stress that it is proprietary, the port aggregation protocol. And then we're going to look at the open standard. Now, they refer to it here as 802.3 AD. Know that this is a legacy reference to LACP. The current reference for LACP is 802.1 capital A, capital X. And we might see that later on here in the activity, but just know that 802.3 AD used to refer to LACP, the Link Aggregation Control Protocol, which is an open standard. However, it's no longer 802.3 AD. It falls under 802.1 capital A, capital X. So 802.1 AX, capital letters at the end there, and that makes a difference. Now we're going to configure, and then we're going to configure a redundant Etherchannel link. So again, a few things to remember. PAgP Cisco proprietary, which is why it's not heavily used because LACP gives you some other bells and whistles that I'll talk about here in a second. So we're going to do PAgP, we're going to do LACP, and we're also going to be doing LACP as active passive. And we'll see the different keywords we can use for LACP and PAgP, and then what I just like to refer to as hard coding the Etherchannel as on, which is not recommended. Again, I stressed that last Monday during our lecture. The on mode is definitely not recommended. All right, so let's go ahead and dive in here. You can see we've got different interfaces we're going to be dealing with, and we're going to be creating some Etherchannel links between these switches. So right now, let's take a look here on switch 1. And again, one of the first things it wants us to do, we'll go from user exec to privilege exec into global config. And I'm going to throw a host name on here of just S1. And you'll notice we get a single percentage point for that command. So I'm going to say no IP domain dash lookup, and I'm going to go into the console line con 0, and we're going to say logging synchronous. So the no IP domain lookup, again, as a review, is if I mistype a command, I don't want it to be considered a host name that tries to get resolved by the device through DNS. So I say no IP domain lookup. And that means if I throw a typo in there, that we're going to be saved from having it say translating ... And then the logging synchronous is so that the log messages will come to the screen synchronously or to the console synchronously. And I get my prompt back because we're going to see some messages that are going to come up on the screen here from the Etherchannel going up and down and ports going up and down. So we want to be prepared for that. I'm going to do these same 3 things on all of my switches. So here we are out in, and let's go ahead. They look like they want us to be in privilege exec. Let me say show interfaces include Ethernet. And this is going to show me the interfaces that are on this router and what their current status is. I can say show interface status as well, where if there was a description, you would see that under the name column. So show interface status is a good command if you have faith in the descriptions that you've placed on the ports. And then let me say show interfaces trunk, and we talked about this on Monday. This is a critical command because this is going to show me, 1, if I have trunk ports configured on the switch, and 2, what the status of those trunk ports is. All right, so we've run those commands, and then we're going to be configuring all the ports that are required for Etherchannels as static trunk ports. And so static trunk port is another way of saying hard coding it as a trunk link, forcing it to be in the on mode. That is your static trunk port. And we do that with the switch port mode trunk command. Now, remember that DTP plays a role on the 2960 switches. And specifically, the dynamic trunking protocol is set to dynamic auto mode, meaning that's why when I say show interface trunk, you don't see trunk links on switch 1. You're not going to see trunk links on switch 2, show interface trunk, and you're not going to see trunk links on switch 3. And this is what I referred to as what causes a bunch of confusion with learners new to trunking, is that they see the connections between the switches here, and they automatically assume that these are all trunk links. They are not. Just because you plug two switches together does not mean that a trunk link automatically forms. It just doesn't work that way. Now, on older Cisco switches, as I referenced the 3550, which again, you're not going to find that in a production environment. If you do, run. But the 3550, it was set to dynamic desirable by default. And that caused a lot of security concerns, which is why today on all newer Cisco switches, it's dynamic auto, meaning that if I plug in two switches together, take them out of the box, plug them together with these links right here, all I've done is extend VLAN 1. I've extended the broadcast domain for VLAN 1 because these are all access ports. And we can prove that. If I say show interface gigabit Ethernet, not gigabit Ethernet, fast Ethernet 021 switch port. Switch port. And let's take a look. Here's the administrative mode. In other words, what's the mode that the port is configured in? And here it's the default, dynamic auto. And look what happens when both sides are dynamic auto. The operational mode falls back to static access. It is not going to be a trunk port. Right? One side has to be dynamic desirable or, as the activity refers to it, static mode or hard-coded to be a trunk port for the link to negotiate with DTP, to negotiate and become a trunk link. And so that's why right now we have no trunk links. All we have are a bunch of access ports that are all in VLAN 1. And it says it right there. I'm telling you, this command, keep this command in your networking toolbox. Show interface, the interface switch port on the switching side of the house. This is a command worth its weight in gold when you're looking at interfaces, trying to figure out why they're behaving the way that they are. Excuse me. All right, so now let's go ahead and dive in, and we're going to configure port channel number 1. And we're going to come up here on switch 1 and make this happen. So let's go from privilege exec into global config with the configure terminal command, or just conf t. And it actually wanted us to run a few commands. So if we said do show interfaces trunk, which we've already done, we don't see any trunk links right now, right? And that's what it's asking. It says ensure you use show interfaces trunk to ensure that you have active trunk links on those two links. And the native VLAN is both the same. And actually, let me take a step back here because I think they may have been asking us, and it's interesting here. So they show it here to do the configuration. I guess I'm trying to figure out. Okay, I guess they just want us to configure it. Yeah, I'm sorry. I'm looking at the sequence here, and I'm trying to figure out why they're having us do show interfaces trunk. And it's probably me just misreading the instructions here. So we're going to go ahead and configure both sides as trunks, and then we're going to run that command to show that we've got trunk links, and we'll bring everything up as we go along here. So here we are on switch 1. Let's go ahead and say interface range fast Ethernet 021, 21 to 22. And again, they kind of help us out here. They give us some of the commands. Now, shutting the interfaces down is always a good idea to make sure that you don't have some sort of a transient state happen and possibly cause an issue in the topology or instability when we're bringing these ports into the ether channel. Again, I've done this a million times without shutting the ports down. I've done it a million times with shutting the ports down. But best practice is probably go ahead and shut your ports down. All right, so we've got them shut down. So let's go ahead and say, channel group 1 mode desirable. Now, before I hit enter here, let's take a look at the different modes that we've got. Active and passive are LACP. Auto and desirable, just like the dynamic trunking protocol. So Cisco actually made this really easy to relate to, because DTP, the dynamic trunking protocol, has two modes, auto and desirable. If both sides are auto, it's not going to form a trunk link. And the same is true here. If both sides are auto, it'll never form an ether channel, right? You're not going to get a port channel out of this. One side has to be desirable. Now, where things are different is this on mode. Now, a very key takeaway here, you cannot mix and match the ether channel modes. So unlike the trunking side of the house, where I can say switch port mode trunk, and if the other side is DTP mode auto, we get a trunk link forming. That is not how ether channel works. Here's where the analogy sort of breaks down. The on mode, LACP and PAgP are all mutually exclusive and not interoperable from each other, right? So you're either going to do LACP on both sides, or you're going to do PAgP on both sides, or you're going to static mode hard code on both sides. You cannot have one side be on and the other side PAgP. You can't have one side be LACP and the other side PAgP, and you can't have on or LACP. There is no mixing and matching of any of the modes in ether channel, right? So remember that. It's extremely important to remember that. You cannot mix and match these modes on the same links between devices. Now, the question that comes up is, what if I had 4 links here, right? We'll do some extra links. Could I do PAgP on those 2 links and LACP on these 2 links? And the answer is yes, because these are different ether channel, port channel interfaces. So yes, as long as the member links in the same channel group are the same, you're fine. You cannot mix and match them in the same port channel. And I'm using ether channel, port channel, and this channel group we're creating as sort of synonymous terms, right? And then, so if switch 2 has LACP here, and we'll say PAgP here, could this be static mode, hard-coded to be on mode, and have all of that on this same switch? Absolutely, because again, we're keeping with the rule that we're not mixing and matching on opposite sides of these ether channel links, right? So keep that in mind. Again, these are some of the little tricky things that can pop up with ether channel. So we're going to say channel group 1 mode desirable using PAgP. And then I'm going to say no shut. Now, this is also a key takeaway here. If I say do show run, there's my port channel interface, right? And again, the port channel number is the number from the channel group command. So channel group 5 would give me port channel 5. Channel group 99 would give me port channel 99. That is where this number is coming from. Now, you'll notice that there's no settings here underneath this interface. There's no description. There's nothing saying if it's an access port or if it's trunk port. And when we come down here, you'll notice the exact same thing. Now, here's the beauty of manipulating the logical interface, right? Remember, PO1, port channel 1, the logical PAgP interface represents these physical interfaces. So we've taken the physical interfaces and we've kind of bonded them, glued them together, right? And creating we've aggregated them together in the Juniper world. You hear the term link aggregation group, or LAG, gets used quite a bit. So we've aggregated these physical links into a single logical link. Now, what that means is I can manipulate this logical interface, and the configuration commands, for the most part, will propagate down to the member interfaces. And so let's see, we're going to see what that looks like here in just 1 second. So we're going to come over to switch 3, and we're going to do the exact same thing that we just did. We're going to get into global config. I'm going to put a host name on here. Let's knock that out. We don't want to miss any points there. No IP domain lookup, because I am the king of typos. We'll say linecon 0, logging synchronous. And then interface range, fast Ethernet 021 to 22. We're going to shut those links down. For good practice, we're going to say channel group 1 mode desirable, and then I'm going to bring those interfaces up. Now, you might think that, okay, you did the Ether channel with PAgP, so now we have trunk links, right? Well, let's come back over here, and I thought we said no shut on those interfaces, and let me go ahead and at this point I'm going to hit the arrows here to get things scooting along. So you might think that right now, if I say do show interface trunk, we're going to see trunk links. Wrong. We haven't made or configured any of those links to be trunk links, right? We haven't done that yet. And the same is true over here on switch 1. Do show interface trunk. There's no, do show interface trunk. There are no trunk links here. So we've got to configure those. And that's exactly what creating the port channel interface down here is talking about. So we can go to the port channel interface, and from there on the logical interface, make changes that will impact all of the member interfaces of that logical interface, or that make up that logical interface. So how do I do that? Interface PO1, right? And let's go ahead and say switch port mode trunk, and we're going to say switch port no negotiate. Let me put a description on here, and this is just going to be, we'll say, here's what we'll do. We'll say PAgP, bundle, and trunk link. So we'll put a description on here. Now let's say do show run. Let's see what gets pushed down. So I've got a description, and there's my switch port mode trunk and my switch port no negotiate command. In fact, stop right here and say do show interface trunk. So you can see that it shows that we're kind of set up and ready to go. And you can also see that it doesn't show the member interfaces. It shows the logical port channel interface. And again, Ether channel, port channel, synonymous terms as I use them as we kind of work through the activity here, along with bundle, right? So to be specific, I'll go ahead and I'll keep with port channel. So port channel 1, you can see the mode is on in terms of trunking, right? We said switch port mode trunk. What is the only encapsulation for trunking on the 2960s and on newer Cisco switches? Same thing. It's 802.1q. And what is my status? I'm trunking. The native VLAN is 1, and I don't believe we manipulate the native VLAN in this activity. So we're just going to leave that as VLAN 1. So things look good from the trunking side of the house here on switch 1, but we know that it's not up, or I should say that it's not fully configured because we've got member interfaces down here and on the other switch. And take a look at that. So the description does not come down onto the member interfaces, but the key configuration commands, the switch port commands, do. And now we're fully set up on this side. And you can actually see I haven't even been looking down there, but we're at 30%. So now let's come over here to switch 3. We'll transition back to switch 3. And we've got everything set up, and we're in the interface range, and we have brought the links up, but now we need to get into interface port channel 1 and say switch port mode trunk, and then say switch port no negotiate, right? So now say do show interface trunk, and let's see what we've got here. There it is. There's our trunk link, right? Everything looks good. But more importantly, let's say do show Ether channel summary. And as you can see here, we've got port channel 1, the S and the U, if you refer up here. Think of S as switch for layer 2, switching. And U, think of it as in use, that these guys are in the bundle and they've been bundled up and they are in use. And that P means it is in the port channel. Now, other letters that you might see right in here is a capital I, meaning standalone, meaning something's wrong. And in the video that I did, or I should say in the lecture that we did where we were recording that 16 port Ether channel between two physical 2960s, we saw W, meaning it was waiting to be aggregated as a hot standby because we were doing LACP. And remember some of the trivia that you might run into. Maximum number of links in a PAgP Ether channel or port channel is 8. In LACP, the maximum number of links is 16, with 8 being active, meaning you could have 8 standby. They call them hot standby. All right, so there's our setup for PAgP on switch number 3, and it looks like we are good to go here. And let me come down. Oh, and let's go ahead and say do show spanning tree, right? Because take a look at what we've got. Fast Ethernet 21 and 22 don't show up here. What does show up? The logical port channel interface. So in other words, we're not going to be seeing the member interfaces in spanning tree. We're going to see the logical interface that represents those individual physical links, right? Because spanning tree is going to treat this logical link as a single link, even though it is comprised and made up of multiple individual physical links. All right, so now we're going to get into 802.1ax. Again, they refer to it as 802.3ad here, but it is currently, current day, referred to as 802.1ax, and this is a legacy reference to spanning tree. All right. I'm sorry, legacy reference to LACP. I said spanning tree. I apologize. All right, so we're going to go back over here to switch 1, and now we're going to do LACP. So we've done PAgP. Pretty simple, right? Channel group mode 1, or channel group 1 mode, either auto or desirable. And now we're going to get into LACP, where it's either going to be active or passive. So let's say interface range, gigabit Ethernet 0, 1 to 2. We're going to shut those interfaces down. We're going to go ahead and say, whoops, sorry, channel group 2, mode active, right? So this is going to be an active LACP side of the configuration, and then I'm going to say no shut. I can go into port channel 2, interface PO2, say switch port mode trunk, and then say switch port no negotiate, right? And those are good best practices. Again, we would change the native VLAN as well along the best practice lines, but that would complicate this activity and kind of pull our focus from where it should be. So now they kind of take away what it is you're going to be doing, and they're basically asking you at this point, hey, you're on your own here on switch number 2. So let's get into global config. Let's first throw our host name on here of S2. Let's say no IP domain lookup. Let's go into line con 0. We'll say logging synchronous. And then let's get into interface range, gigabit Ethernet 0, 1 to 2. And we're going to shut those interfaces down. We're going to say channel group 2 mode, and it wants it to be active. So we're going to do the exact same commands. And then I'm going to say no shut. We're going to go into interface PO2, and we're going to go ahead and say switch port mode trunk. And we're going to say switch port no negotiate. And you can see there that spanning tree, right, when we made it a trunk port, unblocked port channel 2 for VLAN 1. And VLAN 1 is the only VLAN that we have right now. So on this side of the house, let's go ahead and say do show interface trunk. We should see that we do have a trunk link, PO2. What about a do show Etherchannel summary? And there it is, right? We're running LACP, and everything looks beautiful, right? As long as we see this capital P in here, right, and we've got our S for layer 2 and the U, meaning that it's in use, we are going to be good to go. But we've got some additional work to do here on switch number 2. And now they're going to walk us through having one side. This is the redundant Etherchannel link, right? Redundant meaning, that we're now kind of creating this loop between the switches with these trunk links. We're going to get into interface range fast Ethernet 023 to 24. We're going to shut those links down. And I think what's interesting up here is you'll notice that they don't have us shut it down. But again, I'm just going to go ahead and shut it down. And maybe they don't have us shut it down because this side is going to be, I'm trying to see here what they want us to do. Mode passive. Oh, I see what they're, okay, so they're walking through the modes. We've already done that. So it's funny, it doesnent say shut down up here before the channel group, and it looks like they want you to circle back and shut it down. Again, you're going to be okay either way here. So I went ahead, shut them down. So let's say channel group 3 mode passive, right? And what this means is this side of the LACP ether channel is not going to actively try to form an ether channel. It's going to be willing to do so, but it's not going to try to do it, right? It's going to be sitting there kind of, thinking, well, if somebody wants to be an LACP ether channel with me, I'll do that, but I'm not going to make that happen. I'm not going to ask people to be an LACP ether channel. All right, so we're going to say no shut. We'll go into interface PO3 where we say switch port mode trunk, switch port no negotiate. All right, so that takes care of switch number 2. So let's go ahead and do a write mem there. Let's come over to switch number 3, right? Because now it says on switch 3, add those links to the ether channel. So let's get into, we're in global config. Let's say interface range, fast Ethernet 0, 23, and 24, where we're going to shut those down. We're going to say channel group 3 mode active on this side, right? Then we're going to say no shut. And we're going to go ahead and say interface PO3 switch port mode trunk switch port no negotiate. All right, now it's at this point where I believe we should have all of the links configured properly here. And hold on one second. Did I forget to shut down? Okay, I did not. All right, so let's come over here. Let's hit the arrow. Let's get things cruising along here, because now we're interested in some spanning tree, right? Because remember, logically, that is a single link. This is a single link. This is a single logical link between these switches from a spanning tree perspective. And we can see that, we save our config, if I say show spanning tree. And here it is. You've got PO1, which consists of 2 physical links. And then you have PO2, which also consists of 2 physical links, but spanning tree is treating it as a single port. And remember, it was in that demonstration I gave you with the 16 links. If none of those are trunk links and they're not in the ether, I should say, if none of them are in the ether channel, spanning tree is blocking 15 of those links between the 2 switches, right? So we take a look, and they want us to take a look at show spanning tree active. So let's take a look at that output there. And as you can see, it looks very similar to simply show spanning tree, right? So we get the information that we're looking at. It says, and they're on switch 1 here. So it says port channel 2 is not operative because spanning tree had to place that port in blocking mode here on switch 1. So let me ask you, how can we determine which switch is the root bridge here? Well, we look at switch number 1, and if it's got ports that are blocking, and again, we're talking about VLAN 1 and only VLAN 1 here. So if these are blocking, right, and you can see right down here, the role is alternate, and they're blocking, this is probably not the root bridge, because if this was the root bridge, these would be forwarding, and the role would not be root ports, they would be designated ports. But we can look at switch 1 and see that, okay, PO1, this link here is the root port, meaning it has the lowest cost to get to the root bridge. So that is its root port. You'll also notice the cost is lower than it would be if it was a single fast Ethernet link, right? And again, port channel 2 is made up of gigabit Ethernet interfaces, which is why we see the disparity here in the cost. So again, let's come over here to switch number 3 and let's say show spanning tree. Is this the root bridge? And here's the root bridge information at the top, followed by this bridge's ID, this bridge's information, right? Here's all the information for this switch, but here's the information for the root bridge. And take a look. This bridge is the root. And the reason it's the root is all of them have the same default priority of 32.768. So if that's the case, remember, spanning tree, lower is better, and there is never a tie. Ever. Never, ever a tie. So if all of the switches have 32.768, we have to have a tiebreaker. That tiebreaker turns into the globally unique MAC address for the switch. Lower is better. There's never a tie. So here's the MAC address for switch number 3. Let's look at the MAC for switch number 1. And we can see here it's 00A. Well, 001 is lower than 00A. You hit that first number that's different, and you look at which one is lower. And the same is true here on switch 2. If we come back over to switch 2 and I say show spanning tree, what do we see for the MAC address of this bridge? 009. So you have 001, which is switch 3. You have 00A, which is switch 1, and then 009, which is switch 2. And the lowest is always better. There's never going to be a tie, so it's going to be switch 3. And that is why you have the designated ports on switch 3, because it's the root bridge. All ports for which this switch is the root. So let me rephrase this, right? I want to make sure I'm clear here, because we're only dealing with VLAN 1 here. So my statement is, for all of the VLANs for which this switch is the root bridge, all ports will be designated as the role and forwarding as the state. And since we only have VLAN 1, that is why all of the ports are the designated role, because it is the root bridge for all VLANs right now, and would be the root bridge if I created 50 VLANs. Switch 3 is still going to be the root bridge for all of those VLANs, right? And we talked about that per VLAN spanning tree, or rapid per VLAN spanning tree, where we can manipulate and engineer which VLANs would be considered, or which bridge would be considered the root bridge for which VLANs. And so again, we're going to manipulate the spanning tree down here using a macro in just a second. But again, remember, switch 3 is the root bridge because it has the lowest MAC address. The priority is looked at first, but if we don't manipulate that, then it's the MAC address, right? Because the priorities are all going to be the same. And remember the system extension ID. That is nothing more than the VLAN number, right? So we only have VLAN 1, we see system ID extension 1. If we had VLAN 10, we would also see spanning tree for VLAN 0010 for 10, and we would see system ID extension 10. And that gets added to the priority here, right? But when you're setting the priority, you're not setting it to 32,769. You're setting it in increments of 4096, which we're going to see here right now. All right, so port channel 2 is not operative here on switch 1, and apparently we want switch 1 to be the root bridge, so we're going to make that happen. So we're going to come over to switch 1, and there's 2 ways that we can do this. I can go into global config, and I can say spanning tree VLAN 1. Now remember, this is because we're only using VLAN 1. If I was using other VLANs, I can manipulate and engineer which VLANs think switch 1 is the root bridge for those VLANs if we wanted to do some load balancing, for example. So again, I'm just going to say VLAN 1, right? But I could say, like it shows here, oh, this is going to be the root bridge for VLAN 1 and then 99 and then, 200 or something like that, right? But we're only working with VLAN 1. Now, this is considered a macro, because when I say spanning tree VLAN 1 root primary, in this scenario we're looking at, what really gets run behind the scenes, behind the curtain, what's happening is iOS applies this command, this setting, spanning tree VLAN 1 priority 24576. And I'm going to show you the priority values you can use here in just a second. So let's go ahead and say root primary. And I'm going to hit enter. Now, you'll notice, excuse me, that what's going to happen. It says you may have to wait for spanning tree, and we're not going to hang around here. We're going to, yeah, see what happened there? So I'm going to hit the fast forward arrows down here, right? Because we don't want to wait. It could take all day. So I hit the fast forward arrows, and now where are the blocking ports? Well, the blocking ports are over here on switch 3. And now switch 1 has become the root bridge. And here's the scenario where you might want this to happen. here's a PC, right? Or let's say you've got, 100 PCs over here behind switch 3. And over here behind switch 2, you've got another 100 PCs, okay, or 20 PCs or whatever. And this switch connects to your router on a stick that goes out to the internet, right? You wouldn't want blocking. You wouldn't want these to be blocking here, right? Because then PCs over here would have to come this way to get up here. And these are gigabit Ethernet ports over here. Remember that, right? So what we would want to do is what we just did, which is make this the root bridge, because it's from the root bridge that the rest of the spanning tree topology is built, right? So now the PCs can just go this way over this ether channel, this PAgP ether channel, and these PCs are going to go this way, the most direct path to get them to switch 1 to get them out to, we'll say router 1 that takes us out to the internet. And this is one of those use cases for doing things like that, right? Where you would want to set things up so that this is my root bridge. So now let's take a look at the priority values, right? Because I said there's one way that's one way you could do it, right? Now, before we do that, let's just say show spanning trees are going to be in here. We'll say do show spanning tree. We'll just start from scratch here. And now take a look. Here's the priority of this bridge, this switch. Remember, bridge and switch are synonymous terms, even though functionally they're different. This is just a leftover from the olden days when they used to be bridges, right? And things were implemented in software. Now with switches, they're implemented in hardware. So you can see here's the root bridge information, and it just so happens that this is the root bridge. And it shows the priority for VLAN 1. Let's come over to switch number 3, right? Because switch number 3 now has some blocking ports here. So what about a show spanning tree here? So here's the root bridge information for the VLAN in question, VLAN 1. And this gives me the information. Here's the MAC address for the root bridge. Now remember, the number one decision maker for who the root bridge will be for the VLAN in question is the priority, not the MAC address. Remember, we look first at the priority. Now remember, initially the priorities were all the same, so then we go to the next criteria, the MAC address. However, we changed the bridge priority up here on switch 1. We set it to 24576. So it is lower than 32768. Therefore, switch 1 is now the root bridge, and the MAC address is irrelevant. We never get there because we look at that first criteria, the MAC address. So switch 3 says, okay, that's going to be the root bridge, and here's my cost to get to the root bridge. And you can see that it shows that the cost is 9 to get there, and here's port channel 1. And it is my root port because that's the port out which I would go, the logical port out which I go to get to the root bridge that has the lowest cost to reach the root bridge. Because again, here it's a directly connected scenario. Now, just because it's directly connected does not mean that it will always be the root port. Because if the links between switch 2 and 3, if these were gigabit Ethernet links, this would be the alternate blocking port, and this link would be the root forwarding port, because the cost to get to the root bridge, which would be, according to what packet tracer is showing, would be 6. And the reason I'm saying that here is if we said show spanning tree, you can see that the cost for a 2-link bundle is going to be 3. So it would be 3, 6, and not 9. Right? Now, another quick note, these cost values, and I did another video where I walk through adding link by link links into a bundle. These costs are not wholly accurate. They're not totally accurate in packet tracer. On real Cisco switches, they are accurate, but in packet tracer, they are not. All right, so we've done that. Let's look at the other command I could have run. And what I could have said here was spanning tree VLAN 1 priority, right? I could just simply hard code the priority. When you use the macro, there's some, exchanging of BPDUs, the bridge protocol data units, to see what the lowest priority is. However, the macro sets it to 24,576 if everybody else is 32,768. Now, best practice is if that's going to be my root bridge for the VLAN in question, VLAN 1, I'm going to set the priority to the lowest value. And you might be asking, well, what is that lowest value? So all you have to do is type in a bogus value, and it's going to give you all the possible values starting at 0. Remember, lower is better. There will never be a tie. So 0 is the ultimate lowest value that you can have. And if you wanted switch 1 to be the root bridge for VLAN 1, you would set the priority directly to 0. You would typically not use the macro. And if you have a secondary switch that you want to be a secondary root bridge, right? You would set the VLAN 1 priority on that switch to 4096, the second lowest possible value, right? You're typically not going to be messing around with the macros here. You're going to want to hard code it because you want it to be predictable and you want it to be something that's easy to remember. So lowest value is 1, and they go up in values or increments of 4096. All right, so we've got some guidelines and specific things here. Definitely read through this. This is extremely valuable material, but we're at 100%, and we've covered quite a bit of ground here. So let's punch out to the slide. And that is going to do it for Packet Tracer Activity 6.2.4, where we configured Etherchannel. And we went over a lot of information. All right, thank you guys so much for watching. And as always, I hope to see you in the next video.